Hello everyone, so today I'll be explaining my code about Wi-Fi hacking. So let me read the overview. The overview for this program is Wi-Fi Hacker is a Python-based tool designed to automate the process of scanning Wi-Fi networks, capturing WPA, WPA2 handshakes, and attempting to crack the Wi-Fi password using a wordlist. It is only intended for educational use only and authorized security testing only. So this tool abuses sleek password like rockyou.txt to try and decrypt the handshake. So if the password has a weak password, so it might get cracked fast. So this is a good way to show network security. So the requirements for this program, the operating system that I use is Kali Linux. So you will need Python 3.6 and above. So root privilege is required. So you must have a wireless card that supports monitor mode and injector modes. So you also need to install the dependencies and all of that. So you can read all of that if you want. So let me read the pillars of OOP that was used in this program. So let me define it first. So the four pillars of OOP object is the four pillars of OOP. Object-oriented programming is or OOP is a paradigm that organizes code into objects, promoting the usable, scalable, and maintainable programs. The four core pillars of OOP are number one, encapsulation. Encapsulation is the concept of restricting direct access to some of the object's component. It hides the internal state and requires all interaction to be performed through methods. This improves modularity and protects object integrity and preventing unintended interference. So the next one is abstraction. Abstraction focuses on exposing only the relevant details of an object while hiding its internal implementation. It allows developers to interact with complex systems more easily by working at a higher level of logic, reducing complexity. So number three is inheritance. Inheritance allows a class called child class or subclass to inherit attributes and methods from another class called parent class or superclass. This promotes code reuse and establish a natural hierarchical relationship among classes. So the last one is polymorphism. Polymorphism means many forms. It allows methods or functions to operate on objects of different classes through a shared interface, enabling the same operation to behave differently depending on the object it is acting upon on. So that is all. Let us go now to the code. So we are currently at Wi-Fi base class. So Wi-Fi base acts as the cornerstone of the Wi-Fi cracking framework, providing essential utilities for command execution, logging, and file management across all modules. It establishes standardized patterns for sub-processes, handling, debug output, formatting, and error management, ensuring consistent behavior throughout the application. So the class serves as the architectural foundation that enables seamless integration of all Wi-Fi related operations. So the OOP pillar that was used here is basically inheritance. So this is designed to be the parent class for almost some of the Python file that the class that was going to use. So the other one is encapsulation. So modules utilities like run CMD and log message conceal complex sub-processes into manageable details. So we just have to use log message and run CMD to run the shell. So next one is abstraction. So run CMD abstract away sub-process creation and error handling provides a simplified logging interface regardless of debug mode. So reduces the complexity throughout a well-defined method and signature. So polymorphism is also present here. So allows the child classes to override key methods just like run CMD again. So it can run many commands, different commands, regardless of where they come from, as long as they use run CMD. So let us go now to Wi-Fi interface. So Wi-Fi interface handles the critical functionality of wireless interface mode management, specializing between the transition between monitor mode and manage mode. Necessary for packet capture operation, it maintains the original interface state for proper restoration and ensure the network card is properly configured for each phase of the cracking process. So first of all, the OP method that was used here is inheritance. So it inherits Wi-Fi base, Wi-Fi base core operation. So this has all the this in the Wi-Fi interface. So encapsulation was also used here. So it encapsulate IW config command like the enable monitor mode. So here, so this one's enable monitor mode and this one is disable monitor mode. So it also resets the original mode. So it takes the original mode from here. So it will run the command here. IW config. So interface is WALN. So it will know what is it. So it can return to the original modes. So abstraction is also present here because it presents a simplified control interface for mode management. So abstract low-level commands execution details and provide intention revealing method names. So let us go now to Wi-Fi scanner. So Wi-Fi scanner performs comprehensive wireless network discovery and analysis utilizing ear AeroDump-ng to scan for WPA networks and evaluate potential targets. So it processes raw scan data, applies filtering rules, and identify optimal targets based on signal strength or user specified criteria, serving the intelligence gathering component of the system. So first of all, this uses inheritance. So based on this, so this is basically the child class of Python-based. So it also uses encapsulation. So here in scan network, so contains the complete logic for scanning networks without using all of this one because this is too messy. So I have created a function that a method that do that all the job with us with this. So abstraction is also present here because here is, let me show an example. So it's valid WPA network. So presents scanning as a simple unified operation, abstract complex CSV parsing and data processing. So provides a validation through validation methods. So it's valid WPA network. So polymorphism is also here. So analyze scan result, process different CSV formats polymorphically. Validation methods handle various network configuration and supports multiple scanning strategies through common interface. So let us go now to capture handshake class. So the capture handshake class specializes in sophisticated tasks for capturing WPA handshakes through coordinated packet capture and the authentication attacks. It manages concurrent processes for monitoring network traffic and forcing clients to re-authenticate, then verifies successful handshake capture, serving as the critical component that obtains the cryptographic material needed for cracking. So the OOP principle here is inheritance. So it inherits. It also have a class variable. So encapsulation. So it hides here. It's present here. So it hides the send the out packets and many more. So send the out loops. So it hides complex threading in the out loops and contain complete handshake verification logic and manages concurrent process and coordination. So abstraction is also used here at captured handshake. So so it simplifies a multi-step process. So That is all for abstraction. So polymorphism is also here. So it also has the last part. So here. So it handles multiple BSSID formats. Status reporting works with different result types. Support bars capture techniques through common interface. So let us go now to WPA cracker. Okay. So cracker orchestrates the complete password cracking workflow, from converting packet capture to hash formats through HCXP, CAP, PNG, NG tool to executing dictionary attacks using hashcat. So it manages the entire cracking process, including conversion, wordlist handling, and result extraction, serving as the component that ultimately reveals the network password. So first of all, it uses inheritance. So it also uses encapsulation because contains complete hashing, cracking the logic crack using crash hash. So abstraction is also present here. Present Abstraction presents a cracking as a sequence of simple method calls, hides complex hashcat configuration details, and simplifies the result extraction process. Polymorphism is also present here, so it works with multiple hash files formats, processes different result file structure, and handles various wordless types polymorphically. So this uh, this is the most common word list that is present on almost Linux. This comes pre-installed in Kali Linux. So let us move now to Credential Logger. So Credential Logger provides a secure, persistent storage for crack credential formatting and saving successful results with timestamps and standardized structure that ensure capture passwords are properly recorded for future reference and maintains a clean, consistent output format regardless of input variation. So the first thing, the OOP pillar that was present here is encapsulation. Isolate all the file handling operation, protects file access through method-based interaction, and manage file format and structure internally. So polymorphism is also present here. So save credentials handle different credential format, process various timestamp formats, and support multiple output destination. So let us move now to Wi-Fi Hacker. I, this is the common word list, by the way. So the purpose of Wi-Fi Hacker is coordinate the entire Wi-Fi cracking workflow, managing the sequential execution of scanning, handshake captures, and password cracking operation, and it orchestrates component interaction, handles error condition, and ensure proper resource cleanup, serving as the central controller that brings all the pieces all together into a cohesive process. So I have imported all the modules here, so you can look at here. So the next one is the OOP pillar that was present here is encapsulation. So you can look here at execute. So bundles a complete framework and so I can just use execute. So it will run all of this without me telling him that I need to run that. So that is also polymorphism is evident here. So treats all components through a common interface. Execute works with any valid scanner capture cracker. Supports flexible component swapping. So let us go now to the Wi-Fi cracker app. So the Wi-Fi cracker app class serves as the command line interface and entry point for application handling, argument parsing, and input validation and execution flow. It provides user interaction, display usage information, and translate command line inputs into a concrete operation, acting as the bridge between users and core functionalities. The OP period that was present here is encapsulation. So contains complete CLI handling logic, bundlings, argument, parsing validation, and application initialization. Polymorphism is also here because parse argument handles parse arguments handles different input formats, supports multiple configuration approach, process various commands and line syntaxes. So that is all for the code.